polynomials have different kinds. It can be monomial, binomial, trinomial, or in general, they are polynomial. But how will you know if the expression is not a polynomial? It must satisfy the following statements. Negative exponent, radical sign, which is on the variable. Exponent is a fraction and variable is on the denominator. Example, we have number 1, a squared b. Check one by one. Does it have a negative exponent? Of course, none. Radical sign? None. Exponent is a fraction? None. Variable is on the denominator? Of course, none. Then we can say that this is a polynomial. Number 2, 6g to the fourth h raised to 1/2. First, negative exponent? None. Radical sign. When we are talking about radical sign, that is this sign. Next, letter C, exponent is a fraction. We have here an exponent which is a fraction, which is letter C. Then we can say this is not a polynomial. Number 3, UVW plus W raised to 6. Check. Negative exponent? None. Radical sign? None. Exponent is a fraction? None. Variable is on the denominator? Of course, none. Then we can say this is a polynomial. Number 4, negative 6m to the fifth n plus 2 square root of m. Negative exponent? None. Radical sign? We have here a radical sign. Then we can say this is not a polynomial. Number 5, negative exponents. We have here an exponent which is negative. Then we can say this is not a polynomial. Number 6, 4 over x plus 5. Check. Negative exponent? None. Radical sign? None. Exponent is a fraction? None. Variable is on the denominator. We have here a variable which is on the denominator. Then we can say this is not a polynomial. That is how to identify whether the expression is a polynomial or not. We will now proceed with simplifying rational algebraic expression. And we have number 1, 4x divided by 20y. All you need to do is find a common factor between 4 and 20. 4 divided by 4 is 1. 20 divided by 4, that is 5. And just copy x and y. 1 times x, x over 5 times y, 5y. And our final answer is x over 5y using cancellation process. Or another process is get the GCF. Factors of 4, 4 times 1, x over 20, we have 4 times 5, and just copy y. And divide 4 divided by 4, 1. And proceed. 1 times x, x over 5 times y, 5y. Still, we come up with the same answer, which is x over 5y. Next, what if there is a negative exponent? All you need to do is change this to positive by changing its position. Example, we have 21 and negative 3. Just copy the numerical coefficient. Next, since a raised to negative 3 is negative, change the position. That will become our denominator. We have a cube. Next, b raised to negative 7 will become the denominator, which is b raised to 7. Next, we have a raised to negative 4. To make it positive, change that to numerator. That will become a raised to 4. b raised to negative 3 will become b cubed. Then proceed with division. 21 divided by negative 3. Of course, we have 21 divided by 3 is 7. Next, negative 3 divided by 3, that is negative 1. And in dealing with literal coefficient, just subtract the numerator and by the denominator. We have 4 minus 3, that is a. We will write a in our numerator because 4 is greater than 3. Next, b cubed and b to raised to 7. Since b raised to 7 is greater than b cubed, then b is on the denominator. Next, subtract 7 minus 3, that is 4. Final answer is 7a over negative 1 times b to the fourth is negative b to the fourth. This is our final answer. Next, number 3. If given is a binomial, all you need to do is factor out. Use the GCMF. Common between 3 and 6, that is 3. Next, 3p divided by 3, the answer is p, plus 6s divided by 3, that is 2s. Next, since there is no common factor between p and 2s, all you need to do is copy. Since p plus 2s and p plus 2s are binomial and they are the same, we can cancel out. Then our final answer is 3. That is how to simplify rational algebraic expression.